Greetings and welcome to the video on variable types. Let's get the title on the board here. Variable types. Okay, so essentially what I want to cover here is kind of building off of the concepts of measurement scales, and if you have not already seen the two videos or so that we have done on measurement scales, I would suggest that you go back and watch those. But there are really two types of variables that I want to talk about. And just to be clear, measurement scales are the scales that we're applying to these observations of these variables, and the variable types is a way to kind of categorize them, kind of our variables into kind of two loose groupings. And the first one that I want to talk about is continuous variables. Continuous variables. So the way I think of continuous variables is that they can take on any value within a certain range. So for example here, what are some examples of continuous variables? Let's just throw some out here and then we'll work through one of them. Weight would be an example of a continuous variable. Age would be an example of a continuous variable. If you wanted to get more specific to kind of exercise physiology or physical education, then maybe VO2 max would be a continuous variable. Perhaps reaction time would be a continuous variable measured in seconds here. And so let's take an example of just looking at mass. So let's just say we have a mass of let's just kind of put it out here on a number scale per se. Let's kind of do this. And this is the interval that we're just kind of interested in here. And let's just say it starts at kind of 100 grams, and the interval that we're going to here is just going to be maybe it's a 103 grams. And so if I was to put out the ticks here and let's just call this kind of thirds here, let's call this 101, and let's call this 102 grams. Okay, so from 100 grams to 101 grams, there is really kind of an infinite number of values here. So if we're just kind of talking about this specific distance between 100 and 101, there's really kind of an infinite number of values again. So again, it can take on any value within a certain range. So what are some of the values that you could get here? Well, you could get 100.1 grams. You could get 100.2 grams. If the precision of your scale allowed, you could get 100.247 grams or 100.248 grams. And so the point here is that you can get a lot of different values between these 2 points on this interval, and that makes it a continuous variable. And and you will get meaningful intermediate values. What would be an intermediate value here is that you could get an average or a mean here that represents a real number that's on this particular scale here. Okay, so let's talk briefly then about discrete. We'll just put it up over here. Remember, we have two main variable types, so let's talk about discrete variables. So, whereas continuous variables can take on any value within a certain range, discrete, and by definition, the word discrete means that you can take on separate values. So here, can only take on separate values. Another way of thinking of this is these are countable. In other words, you can get a frequency. For example, let's do an example here. Let's talk about the number of family members. So for our example here, let's just put out a few examples first, and then we'll be consistent with how we did over here. So the one we talked about before, biological sex, political party would be another example, where you're taking on a number takes on a separate value for that particular variable. Let's go through and talk about something like, let's talk about family members. Family members. So, I mean, you can basically say your family has, one individual in it. Perhaps if you're not married, it could have, two individuals in it, a husband and a wife. You could have 3 members in it. You have a child, 4 members in it. You have 2 children, and so on and so forth. The point here is that between these numbers, it doesn't make sense to have intermediate values, right? So you cannot take on intermediate values. What does that mean? It doesn't make sense to say you have 2.56 members to family. No sense. Doesn't make sense, right? And so it's discrete. Your family is either a 1, it's either a 2 or a 3. It's not a 2.56. You don't have 0.56 of a person in your family. Whereas over here on the continuous side, you can have 0.247, and that represents a real value here on your measurement scale. And so it's just important to kind of think about what kind of variables that you're going to have in your study, or when you're reading an article or a piece of literature, to kind of be able to discern what kind of variables they're including in their analyses. Are these variables discrete variables, in that they're looking at the difference between males and females on something? They're looking at a difference between levels of a drug. They're getting 0 milligrams. They're in a control group of something. They get 25 milligrams and then 50 milligrams. So you assign a value where 1 would we'll just do this. So a 1 would equal 0 milligrams of a drug. 2 might mean that they get 25 milligrams of a drug, and the 3 equals that they get 50 milligrams of a drug. These just represent, again, categories. Having something that's 1.75 here is nonsensical. It doesn't mean that they got somewhere between 0 milligrams and 25 milligrams. And so this would be a discrete variable. What would the name of that variable be? The name of the variable would be drug. Drug would be a discrete variable, and it would have 3 levels to it. 3 levels to that discrete variable, and the levels are 1, 0 milligrams, 2, 25 milligrams, 3, 50 milligrams. So when you're reading articles, you want to pay attention to are the variables they're looking at, are they discrete or are they continuous? And this will really kind of help you when we get to the kind of the analysis section. And there's a relationship here, and I will actually try to do another video, short video, describing the relationship between discrete and continuous variables. Thanks for watching.